Chapter 17, the Principle of Linear Superposition and Interference Phenomena. So now that we've learned about waves and sound waves in chapter 16, we're going to see what happens when we have two or more waves that meet each other. It turns out there's some really cool things. So our very first section is this Principle of Linear Superposition, 17.1. And for this, we can imagine having a slinky where we're sending pulses along it, or the wave on a string simulation is another great illustration of this. If you have one pulse moving rightward here, but if you have another pulse that's moving to the left and they both are pulses upward like this, then when they meet in the middle, there's a brief point where they overlap and it becomes twice as big. The two individual pulses add up to this tall pulse, right? And then amazingly, that mountainous pulse disappears and the individual pulses just keep traveling the way they came, right? So if we imagine that this one was a red one, it's traveling to the left. At this point, it is still in here, right? It's only half of it, but it still is traveling to the left. And sure enough, over here on the other side, it's traveling to the left. So they're still traveling independent of the other, but we can get their overall shape by summing the individual effects. That's the basis of the linear superposition, the sum of the shapes of these individual pulses. So this is what happens when we have two up pulses coming towards each other, and when they overlap, they become twice as large. What happens if we flip one of those over? If we make one of them an up pulse and the other one a down pulse? Well, we can think what will happen at that overlap point. We'll have one going up, one going down. Let's take a look at that. So if we have one up and one down, then at that point of overlap, they disappear, right? The one that had been up is still there. It's not gone, but it's being canceled out by the lower one, the one that was down. And notice it still continues on. So even though the pulses totally disappear for an instant, you'll later see that that up pulse is still traveling in the right as it was before. And the down pulse, right, that was traveling to the left and still exists in this overlap, even though you don't see it. It's actually still physically there. And that's why an instant later, you can see it reappear as it continues traveling leftward. This is pretty wild, but it does work. So this is the basic idea of the principle of linear superposition. And we can get a formal statement of it right here. Principle of linear superposition says that when two or more waves are present simultaneously at the same place, the resultant disturbance is the sum of the disturbances of the individual waves, right? So if we have two up waves, we'll get a resultant that's twice as big. If we have an up and a down, the resultant will be nothing. And there's a lot of in between, right? Where it's some strange effect. This is how waves can combine, right? You see this in the ocean, for instance, why there can be sudden surprise sneaker waves, right? Especially in the tropical region like the Bahamas, there's normal waves, but every so often there's another wave that comes in and overlaps with that normal wave, maybe a third. And so out of nowhere, there's this giant wave for just a brief instant, and then it's gone because of the principle of linear superposition, that each of the individual effects can be added to create the overall one. And we're going to see how this can combine in something that we can actually hear, not just see on a slinky, but what will apply to sound. So stick around for the next section.